Hey everyone! So today I'm going to be talking about radioactive particles. There aren't many ways to show this in an awesome experiment, so I'll just have to make this as interesting as possible. Now when someone says radioactivity, a lot of people think about mutation and all the horrible things that radioactivity can do to people. What a lot of people don't understand is that we use radioactivity in a lot of what we do, and as treatments. Radiation occurs when an atom is unstable, meaning it has one or two too many subatomic particles. So in order for it to become stable, it must decay itself. But there are different ways an atom will decay, and this depends on the atom and its isotope. Three main types of radiation are alpha, beta, and gamma radiation. Alpha radiation particles are the least dangerous to us outside the body. They have a large mass and couldn't get through a single piece of paper, let alone our skin. However, inside the body, they could be very dangerous because of their ionizing ability, which could seriously damage your cells. Then there are beta radiation particles. These particles are smaller but can be stopped by some aluminum, but they are more dangerous to us outside the body, and inside the body they'll ionize some atoms, but it's not as dangerous because it's able to pass through your cells and be released from the body, instead of bouncing around inside like the alpha particles would. Finally, there are gamma radiation particles. These particles have no mass and can be stopped by a solid chunk of concrete or lead. Inside the body, they won't do any damage. They'll pass right through your cells, but outside the body, if it is concentrated, it could be very dangerous, or helpful if used right. Now, we don't actually interact with these radiation particles that often at all. One common misconception is that microwaves produce these radiation particles that will harm us, but in reality, they just produce electromagnetic waves that are weaker than the visible light we're exposed to every single day. The only way they heat things up is by using a field to align the polar molecules in what you're heating and allowing the waves to move them around. One use of radiation is in cancer treatment. The example I'm going to provide uses gamma radiation to attack cancer cells, specifically cancer cells inside the brain. The machine used is called the Gamma Knife, and what it does is it takes cobalt-60 and the gamma waves it produces and focuses them through a sort of helmet that is placed over the patient's head frame. This helmet has hundreds of holes in it which are directed towards the lesion in the brain. These holes provide very precisely focused beams directed at the lesion. Since it is so direct, precise, and accurate, the surrounding tissue is undamaged. The gamma particles allow the machine to distort or destroy the DNA of tumor cells, causing them to be unable to reproduce or grow. Now, without all the multiple beams being sent towards the lesion, this treatment wouldn't work, because the gamma particles have no mass and will pass right through you. However, when the particles of the beam cross at the exact point of intersection, the intensity of the particles increased. And with so many beams intersecting, the intensity is enough to kill the cells. So there is an example of radiation that is not harmful to us, and a little bit as to how radiation occurs, as well as why. Bye.